Lesson: AI tools for proactive threat hunting. AI tools for proactive threat hunting have revolutionized the cybersecurity landscape by providing advanced capabilities for identifying, analyzing, and mitigating potential threats before they can cause significant harm. Leveraging artificial intelligence allows organizations to enhance their threat detection and response strategies, making them more resilient against increasingly sophisticated cyber threats. This lesson delves into the theoretical foundations of AI in the context of cybersecurity, with a specific focus on its application in proactive threat hunting. The integration of AI in threat hunting is predicated on its ability to process and analyze vast amounts of data at speeds and accuracies unattainable by human analysts alone. Traditional threat detection methods often rely on signature-based systems, which are limited to identifying known threats. However, AI-driven tools utilize machine learning algorithms to detect anomalies and patterns indicative of novel threats. For instance, AI can identify unusual network traffic patterns that may signify a breach, even if the specific attack vector has never been encountered before. Machine learning, a subset of AI, plays a crucial role in proactive threat hunting. Supervised learning algorithms are trained on labeled datasets containing examples of both benign and malicious activity. This training allows the algorithms to classify new data with high accuracy. Unsupervised learning, on the other hand, does not rely on labeled data, but instead identifies patterns and clusters within the data that may indicate potential threats. For example, clustering algorithms can group similar network behaviors together, flagging outliers for further investigation. One of the significant advantages of AI tools in threat hunting is their ability to continuously learn and adapt to new threats. Unlike static signature-based systems, AI algorithms can update their models based on new data, improving their threat detection capabilities over time. This adaptive learning process is particularly important given the dynamic nature of cyber threats. Attackers are constantly evolving their techniques to bypass traditional security measures, and AI must evolve in parallel to remain effective. The application of natural language processing in threat hunting is another area where AI excels. NLP enables AI systems to analyze and interpret human language, which is invaluable for processing unstructured data such as threat intelligence reports, social media posts, and dark web communications. By extracting relevant information from these sources, AI systems can provide insights into emerging threats and help security analysts prioritize their efforts. For instance, NLP can be used to identify mentions of new vulnerabilities or exploits, allowing organizations to take preemptive measures. AI-driven threat hunting tools also leverage predictive analytics to forecast potential threats based on historical data and current trends. Predictive models can identify patterns that precede an attack, enabling organizations to implement countermeasures before an incident occurs. For example, by analyzing historical attack data, AI can predict the likelihood of specific types of attacks targeting certain industries or geographic regions. This foresight allows security teams to allocate resources more effectively and strengthen defenses in anticipation of potential threats. The use of AI in threat hunting is not without challenges. One of the primary concerns is the quality and representativeness of the data used to train AI models. Biased or incomplete data can lead to inaccurate predictions and potentially overlook critical threats. Therefore, it is essential to ensure that training datasets are diverse and representative of the full spectrum of potential threats. Additionally, the interpretability of AI models is a significant concern. Security analysts must be able to understand and trust the decisions made by AI systems, which can be challenging given the complexity of some machine learning algorithms. Despite these challenges, the benefits of AI in proactive threat hunting are undeniable. AI tools enhance the efficiency and effectiveness of threat detection and response, allowing organizations to stay ahead of cyber adversaries. For example, IBM's Watson for Cybersecurity uses cognitive computing to analyze vast amounts of unstructured data, providing security analysts with actionable insights that would be impossible to obtain manually. Similarly, Darktrace's AI platform uses machine learning to detect and respond to threats in real time, significantly reducing the time to identify and mitigate security incidents. In conclusion, AI tools for proactive threat hunting represent a significant advancement in cybersecurity. By leveraging machine learning, natural language processing, and predictive analytics, these tools can identify and mitigate threats more effectively than traditional methods. The continuous learning and adaptability of AI systems ensure that they remain relevant in the face of evolving cyber threats. While challenges such as data quality and model interpretability must be addressed, the overall impact of AI on threat hunting is overwhelmingly positive. As cyber threats continue to grow in sophistication and scale, the integration of AI in threat hunting will be critical to maintaining robust cybersecurity defenses.